So far in this unit, we have learned how to find a GCF to factor, and we've learned how to factor special binomials that is a difference of perfect squares. So let's take a look at these types of binomials. So these are a little different than the ones we've been working with, right? A difference of perfect squares looked like this, x minus 2, x plus 2, right? Where we had the same thing in front and the same thing in back, okay? So now look at these three examples. Now these three have the same thing in front, but not the same thing in back. So this is not a special binomial. This is just a regular multiplying two binomials together. So these behave a little bit differently. So let's remember how we multiply these first. Okay, so we'll use the area model to do this. So I've got x plus 1 and x plus 5. So I'm going to draw my area model. x1, x5. I get x squared, x, 5x, and 5. And when I combine like terms, 5 plus 1 is 6x. So this becomes x squared plus 6x plus 5. Okay, let's do the second one. The second one is m minus 4, m plus 6. So I get m squared minus 4m, 6m, and negative 24. When I combine these middle terms, I get 2. 6 minus 4 is 2. So I have m squared minus 2m minus 24. And finally, the third one. K minus 7, k minus 3, k squared, negative 3k, oh, sorry, negative 7k, and then positive 21. Combine like terms again, and I get k squared minus 10k minus plus 21. So now, this whole unit has been about reversing the process, correct? So the question now is, we all know how to go from this to this. We all know how to do it. You draw an area model, you get this thing. But now, since this unit we reverse everything, my question is, what if I start with this trinomial and I want to figure out what goes in here and what goes in here? How do I factor this into two binomials? Okay. And it can be kind of tricky because I see a 10 and a 21, but I don't see a 10 and a 21 here. I have a 2 and a 24, don't quite see that here. Now there is a pattern, which some of you might be seeing already, between the numbers here and the numbers here. Between this middle number and the last number and these two numbers. There is a very cool relationship that we're going to learn in this learning target. Okay, so this is our goal, to reverse the process. Okay. So let's take a look at how to start seeing this pattern. Okay, so I've put 4 area models on here. And we did this a little bit in the last learning target where we had that area problem where you kind of put the numbers inside the box and then you tried to find the outside numbers. So that's what we're going to start doing. So there are 8 different ways to fill out these 4 area models, at least. There's a lot more. So I'm going to show you 1 or 2 ways of how to do this. So I've got the x squared right here. So I know that this has to be x and this has to be x because x times x is x squared. So I know that already. I also have an additional piece of information. I have this 12 here. Now there are lots of ways to get a 12, right? One way is I could put 3 and I could put 4 here, right? Because 3 times 4 is 12. And then if 3 is here, this becomes 3x and this becomes 4x. So when I combine like terms, I get this x squared plus 7x plus 12. But the cool part is now that I reversed it, I now know what goes on the top, and I now know what goes on the side. This is a positive 3, so I can put a plus here. This is a positive 4, so I can put a plus there. So the two binomials that work here would be x plus 3 and x plus 4 because those are the things I have on the side. And that times that, the top times the side, will give me this thing in the middle, right? So we're trying to work from the inside out. That's not the only way to get the 12 though. What else multiplies to 12? Well, I can think of another one, and then I'm going to let you think of two more. What about 6 and 2? Does that work? Is 6 times 2 12? Sure. And then that means that this has to be 6x, and this has to be, oh, not 6x, 2x. All right, and when I combine like terms, I get x squared plus 8x plus 12. And now, to figure out the two binomials, I just look at the top, which is x and 6, so that's x plus 6. And the side would be x plus 2. Okay? So now what I want you to do is I want you to try and fill out 3 and 4 a different way than I've done. Okay? Remember, there's at least 8 different ways. There's a lot, because 12, well, there's a lot of things that can multiply to 12. Okay? Don't forget to think about negatives as well when you try 3 and 4, okay? So pause the video and try and see if you can come up with 2 more. So here are 2 that I came up with. The first one, number 3 here, I put 12 and 1. Now you could have put something different, but I put 12 and 1. You could have put 1 on top and 12 on the side. It honestly doesn't matter where you put your numbers, okay? So when I put them in my area model, I ended up getting a 13 in the middle, and then my binomials are x plus 12, x plus 1. The other one I did has negative numbers, right? We don't always work with positives. I had to put a -3 and a -4 because I needed a positive 12, right? So it has to both be negative to get that positive 12. So in that case, -4 and -3 add up to -7. And then on top, I have, and I'll use a different color, or I'll even use a highlighter. I have on top this x plus 3 and this x minus 4, so that's how I got these two binomials. Okay? So let's take it one step further. We have kind of some limitations, right? Every problem won't just be here's 12. Okay, all the problems are going to have a little bit more information. So here's the same area model with the 12, but now I'm given a little bit more info. Now I'm given that this thing in the middle has to be 7, which means that whatever I put into here and here has to add up to 7. So in that case, what two numbers add up to 7 but multiply to 12? Well, I'm thinking 3 and 4. 3 and 4 multiply to 12, but they also add to 7. 4 plus 3 is 7, and 4 times 3 is 12. So now I can fill out this area model specifically, and now I know that this has to be x plus 4, x plus 3. Okay? How about the next one? The next one now says that I've got an 8 here. Oops, I tried to use the highlighter. I don't know why that didn't work. Let me erase that here. Okay, so now I've got this 8 here, and I have to pick two numbers now that when I put them in here have to add up to 8, but also multiply to 12. So I'm thinking 6 and 2. 6 and 2 add up to 8, which is what I need here, but they also multiply to 12. So when I finish filling out this area model and get the top number and the side number, I get x plus 2 and x plus 6. Okay? How about the third one? The third one, what do I need to multiply to 12 but add up to 13? Well, that's just like the one we did before with 12 and 1. 12 times 1 is 12, and 12 plus 1 is 13. So with that little extra piece of information, I can find these a little bit easier. The last one is a little bit trickier because we have a negative, and I know you guys just love negatives. They're awesome. I have a -7 here, which means that I need two numbers that multiply to 12. Oh, I gotta plug my battery in. That's not good. All right, there we go. Okay, sorry about that. All right, so now two numbers that multiply to 12 add up to -7, and I've done this so many times, guys. It may seem like I'm doing this quickly. It's just when you do this a lot, you start to see this relationship of adding to the middle, multiplying to the end. So I know that -3 and -4 will work. I also have this thing missing right here. To get x squared, I know this has to be x. So I'm going to put -4x here and -3x here. So I know that my two binomials are x minus 3 and x minus 4. So at this point we should see a pattern. I've mentioned it a couple times. the pattern is that you're looking for a number that multiplies to this, but adds up to this. That's the relationship we're looking for. Okay, and you'll notice if we go back to the beginning, that's the relationship here as well, right? What two numbers multiply to 5 but add up to 6? Well, isn't 5 times 1 5? But 5 plus 1 is 6? Yep. How about negative 24? Is 6 and times negative 4 negative 24? Sorry, is 6 times negative 4 negative 24? Yes. Is 6 plus negative 4 negative 2? Yep. So that's the relationship we're looking for. So if I go down to this bottom problem, I'm looking for two numbers that multiply to 3 but add up to 2. All right, let's change this to a 4 because that doesn't actually work, and I want to give you a good example. Okay, so x squared plus 4x plus 3. So what two numbers multiply to 3 but add up to 4? That would be 3 and 1. 3 plus 1 is 4, and 3 times 1 is 3. And now I just put my x's in here. Okay? So, I've got a couple strategies to help you do this. So let's write down the formula first, so just so you have it in your notes. So you're looking for two integers that multiply to the last number and add to the middle number. So here's an example. We're looking for, it's x squared plus 10x plus 9. We're looking for two integers that have a product of 9 and a sum of 10. Just cross those out and switch those numbers. Okay, so we're multiplying to the last number, the 9, and we're adding to the middle number. So one way that I do, there's two ways, and I don't care what two ways you do. The first thing I do is I draw an area model. Okay, I know that x squared has to go here, and I know that 9 has to go here. I know that this has to be x and x logically. What I don't know is what goes on the sides. So I also draw this little thing, and it's a way to write out your numbers like a puzzle. So I always put the last number on top, and I put the middle number on bottom. And you're looking for the number that multiplies to 9, adds up to 9, and the bottom number is what it multiplies to. Okay? And one thing you can do to kind of help you, especially with bigger numbers, is if you're multiplying to 9, write out all your options, right? 1 times 9, I could put a 1 here and a 9 here. That would multiply to 9. I could also put a 3 here and a 3 here, and that would multiply to 9. So both of those options work with the 9. But now I got to figure out which two also add up to 10, and I can see that right here. 1 times 9 is 9, 1 plus 9 is 10. So I put the 1 here and the 9 here, put the 1 here and the 9 here, and I fill out my model. Okay. Now my final answer, I don't want any of all this stuff as a strategy to help you figure it out, right? What I need to be your answer is I need the two binomials, x plus 1, x plus 9. So this thing is your answer, and I want you to put a box around it once you get it. Okay, I want to see your work, but I also want you to realize that this is the answer. Okay, let's try a few more. So these two are a little bit confusing. So notice that I've got the x squared, the 3x, and the 18 in this one. In this one I also have an x squared, a 3x, and an 18. But one of them has a positive 3x, and the other has a negative 3x, which is a really big deal. It's going to change what our answers are. So let's go ahead and do this first one, right? So I like to do the x here. I've already got my Punnett square. So what two numbers multiply to negative 18 and add up to 3? So I'm going to go ahead and put 18 here, and I'm going to think of all the factors that multiply to 18. 1 times 18, 2 times 9, 3 times 6. Now, I need to get a positive 3, but I need a negative 18. To get a negative number when you multiply, one of these has to be negative and one of these has to be positive, right? That's the only way you get a negative. So I look at these three options and I say, okay, how can I make one of them negative and get a 3? And I instantly look at this guy. Because if I make the 3 negative and I make the 6 positive, 6 minus 3 gives me 3. So now I know that this is what goes here and this is what goes here. And then I kind of work my way out. This has to be x and x, this has to be 6, this has to be negative 3, and I'm going to write my answer that way. X minus 3, x plus 6. Okay. Over here, I have a bit of a different problem, because now, instead of a positive 3 down here, I have a negative 3. Now, negative 18 still has to be negative, so this has to be negative, this has to be positive. So again, let's make our list. I know it's the same as the other side. When you make your list over here, even though this is negative, you don't need to make it negative when you make your list. It's not necessary, because the factors are going to be the same. 118, 2 times 9, and 3 times 6. I'm still going to hone in on this guy because I know I can get a 3 out of it, but this time I need the 6 to be negative and the 3 to be positive, because negative 6 plus 3 would give me that negative right here, which is what I need. So now I'm going to go back into my Punnett square, I'm going to put them each in here, and then work my way out to get my binomials. So this becomes x minus 6, x plus 3. Okay, the Punnett square is important. Putting it back into the Punnett square is something I need you guys to do. It's going to come up really, you won't be able to do the next learning target without the Punnett square. Right now you kind of can, but I want that practice of using the Punnett square. Alright? I'm going to do a couple more, and then I want you to try a couple on your own. Okay? So I'm going to do numbers 1 and 3. You're going to try 2 and 4. If you want to pause the video now and try all of them, that's fine. I don't care. But definitely we're going to try a couple on our own. So number 1, I'm going to do my x first. Okay? I'm going to put this number on top, the 42, and I'm going to put this number on bottom, negative 17. Watch your signs. Now I'm going to list all the factors of 42. So I've got 142, I've got 221, I've got 314, and I've got 6 and 7. So now I'm trying to look at this and think, how can I get a 17 out of these numbers? 42 and 1 won't give me a 17, 2 and 21 won't, but 3 and 14 will give me a 17 somehow. Now, I have a positive number up top and a negative number on bottom, so that means that both of these have to be negative numbers, because a negative times a negative is a positive, but a negative plus a negative is a negative. Okay, so I'm going to put negative 3 here and negative 14 here. Then I'm going to draw my Punnett square. I'm going to put what I know that goes inside. Oh, it's not x's, it's n's. So I've got n squared here. I'm putting this guy inside. N squared here and 42 here. I've just figured out that this has to be 3n and this has to be negative 14n. So that means this is negative 3, this has to be n, and this has to be negative 14. So my final answer is n minus 3, n minus 14. Okay? Alright, I'll do number 3 and then you guys can try 2 and 4. So number 3, same thing. I'm going to draw my x. I'm going to put 39 up top. I'm going to put 16 on bottom. Now I'm going to figure out all of my factors of 39. I have 1 and 39, and I've got 3 and 13. I'm going to stop there because I instantly recognize 3 and 13 gives me 16. So I've got 3 here and 13 here. Now I'm going to put it in my Punnett square. Put the x squared, sorry, I keep getting my letters wrong. M squared here, 39 here. I now know that 13 and 3 work. 13 times 3 is 39, and 13 plus 3 is 16. So m goes here, 13 here, m here, 3 here. So my final answer is m plus 13, m plus 3. You'll know you're right if this whole thing right here is correct. If this makes sense and all your multiplication is working, you know you're right. So now I want you to try these last 2 on your own. So pause the video and try these 2 on your own. Okay, so you should have gotten n plus 8, n plus 1 for number 2, and you should have gotten x minus 9, x plus 4 for number 4. That one was a little trickier, but you should have written this out to help you find all the factors. Because then you would have noticed at the very end here, 9 and 4 do work. Okay? There's one other step we have to do here in this learning target. And again, this takes us back to that very first learning target we did with a GCF. So remember that beginning rule we had? You always have to check for a GCF first before you do anything else. Okay? Otherwise, you're going to run into trouble. Alright, so in the first one, 4, 12, and 8 all have a GCF of 4. So I'm going to pull that 4 out, and I'm left with k squared plus 3k plus 2. Now I've got this little guy here, this thing, which I can factor further. So now I'm going to take that thing in the middle, and I'm going to do the same thing I did in the last few examples. I'm going to put a 2 here, because that's the last number, and a 3 here, because that's the middle number. Okay, 2 only has 2 factors, 1 and 2. So 1 and 2 have to work. 1 times 2 is 2, and 1 plus 2 is 3. So when I use my Punnett square, and I put my, don't put your original, put this thing back in the Punnett square. Don't put 4k squared and 8. That won't work. You got to put the thing I've highlighted back into the Punnett square. So k squared and 2 here, and then I know 2k goes here, and 1k goes here. So these are both k's, this is a 1, and this is a 2. Now when you go back to write your final answer, you have to bring down the 4 in front of it, or you will be wrong and I will take off points. Okay, the 4 has to stay, it is part of your final answer, and then you break this up into its 2 binomials. Okay, this is your correct answer. Alright, the 4 is included. Alright, I'm going to go ahead and show you this bottom right one, because it's got some funky stuff going on. So here, I'm looking for a GCF first. I notice that within my numbers, I have a 5. Okay, but I also notice within my letters, I have a y, so I also need to take out that y. Okay, when I do that, I'm going to be left with x squared here, 3x here, and a negative 28 here. So now, I'm going to do the same thing I did before. I'm going to go ahead and highlight this because that's what I need to do to keep going. I'm going to draw an x, put negative 28 here, and 3 here. Okay? 2 numbers that multiply to negative 28 and add up to 3. 1 times 28, 2 times 14. 3 doesn't work, but 4 times 7 does, and I notice right away that it's got to be 7 and 4. I need a negative 28 and a positive 3, so I'm going to do positive 7 and negative 4. That will give me a 3, and it will also give me a negative 28. So I'm going to do my Punnett square, put all my info in, negative 28 here. Again, don't use this thing. Don't use the first one, use the second one. X squared here. From my numbers, I know that negative 4x goes here, positive 7x goes here, and now I just fill in the outside to make it match. And so my final answer for this problem is going to be 5y times x minus 4, x plus 7. Okay? Alright, the last 2 are up to you. Go ahead and pause and try to come up with these last 2. I will be checking your notes for work, and I'm only going to put the answers here. So when you come show me, I do need to see that you've actually attempted these problems. Alright, go ahead and pause. Try them on your own. Alright, these should be your solutions for number 2 and number 3. If you have questions about these solutions, please come talk to me before you start your practice. There are a lot of practice problems in this learning target. I mean, a lot. I did that on purpose. I know a lot of you asked me to skip problems, but for this learning target, I really need you to not skip problems. It's going to take you a couple days probably, and that's okay. Alright, good luck on your practice, and you know what to do when you need help.